my only lesson out of fundraising is like be fundraising when your company's in a great situation and you don't need to fundraise. If you need to fundraise, fundraising is really unpleasant. So if I ever start another company from scratch, I will make sure to get some traction, get a product that really has product market fit, have a small core team that isn't burning a lot of money, and then go raise money to accelerate, not just to stay alive.
Welcome back to the Exploring Podcast. My name is Teja, and thanks to each and every single one of you who come back every week to learn, to execute, to exploit, and to clone the thought process and to be able to make a huge difference in your work, life, or business. And there are times in your life that instantly fascinates you about someone's work on the internet, right? And I was really fascinated when I found this incredible organization working on oil and gas production with machine learning and optimizing them for a better business with purpose. So today's guest is an entrepreneur, programmer, author, and a mathematician. As you already know, he is none other than Paul Orland. Before we move ahead, a huge shout out to Sandog Education for sponsoring this episode. Join over 500,000 learners across the world. You can learn machine learning, AI, and big data just for $25 a month. All you need is some prior programming or scripting experience with a high school level math. With a lot of hands-on activities and exercises, you can practice whatever you have learned. Visit sandog-education.com and sign up for a free trial course to start your journey towards a lucrative and rewarding career in the hardest technology. That's sandog-education.com. Now, on to the ad-free show. After a stint as software engineer at Microsoft, Paul is the founder of Tachyus, a Silicon Valley startup having the best minds in the industry, where they use analytics to optimize energy production for the oil and gas industry. As founding CTO of Tachyus, Paul led the productionization of machine learning and physics-based modeling software, and later as CEO, he expanded its user base to customers on 5 continents. Paul has a BS in math from Yale and an MS in physics from University of Washington, and is the author of the amazing book Math for Programmers by Manning Publications. On top of all of that, Paul is the one who focuses on empowering people with technology and math. And I can't wait anymore to start exploring with Paul Orland. Thank you so much for joining us, Paul. I'm super excited to have you on the show.
Yeah, thank you for having me. I'm excited to have a good conversation.
So I'm actually genuinely so curious to know what Tachyus actually means, because I tried Googling out like what's the meaning of Tachyus and Tachyus meaning, and you know what the Googling, like the Google search results came out is like Tachyus is an industry leader in optimizing fields under secondary and tertiary recovery, including water and streaming flooding. I don't know what was that. I'm just asking for the meaning, right? So, and again, the next result is about the About Us page from your website. So what does it actually mean, like Tachyus?
The name Tachyus? So I guess like any startup name, different people will tell you different stories, but I know the original one. And the original one is that the three of us who co-founded the company back in 2013 were all math and physics guys. And we wanted to choose a company name that kind of had some meaning, and eventually we chose to try and do like a physicsy name. So what we did is we kind of took a bunch of physics terms and we went down a list and we changed them slightly to try and get .coms that were available. So we started, the physics term that won out was the word tachyon, which is a hypothetical particle that moves faster than the speed of light.
Cool.
And tachyon became Tachyus, and Tachyus.com was available. So I guess that's probably the real reason behind most startup names, is that the URL they wanted was available.
Exactly. Yeah, it happens with a lot of people as well. So genuinely that URL will actually determine the what company name usually. So yep. It's actually, they need to figure out the domain name first before they register the company officially, right?
Yep, exactly.
So yeah, that's actually good. So, I mean, your team does a lot of work on oil and gas optimization, right? So what does it actually mean? Like when we say like production optimization in oil and gas, so what does that actually mean?
So this is, and by the way, I got into this industry not having ever known anything about it. And we literally did a field trip down from the Bay Area, San Francisco, where we started this company. We did a field trip down to Bakersfield, California, which is about a 4-hour drive south. And it's where, at least at the time, something like 10% of U.S. oil production was kind of headquartered out of Bakersfield. So there's this big kind of industry that's like obviously one of the biggest and most important industries in the world, and it was right in our backyard, and we didn't know anything about it. But so anyway, with that said, I'm kind of new to this myself, and production optimization. So production means in the full process of like extracting hydrocarbons from the ground and turning them into something useful, and then selling them. There's the exploration phase where people are looking for oil deposits or natural gas deposits. Then there's the production phase where they are actually drilling holes in the ground and then pumping fluid out, or fluid is naturally coming out. And then there's all sorts of phases called in this process called midstream, where oil or natural gas are pumped through pipelines or put on trucks or tankers or whatever. And then finally there's downstream, which is kind of refining and preparing end products. So production is like, to give a short answer to your question, production is like figuring out how to efficiently extract the resources from the ground.
Cool. But when did you get this idea of actually, becoming an intersection with mathematics and machine learning and prediction algorithms with the actual oil and gas industry? When did you get this thought of intersecting them and making the best results out?
Yeah, so I think we started looking at what skills we had and how we could bring them to solve a big problem. And one of the we looked at the biggest industries in the world ultimately, and those are at the time were agriculture was number one. I believe oil and gas was number two. Oil and gas was the biggest input to agriculture by dollar value, I think. Then there's other ones like mining and manufacturing and healthcare and finance and education, just like the biggest things in the world. And we kind of just like, we thought about our skills. We said we know how to do data science, we know math, we know physics. What's the biggest problem we can solve and make the biggest impact? And like I said, we went on that field trip. We met a lot of people through our network and learned about various industries. And oil and gas industry was unique because it's not just data science that you can do. There's also real like physical understanding you can have about the systems that are involved. As opposed to finance or something where it's you can have economic models and whatnot, but there's nothing physical going on, so you can't apply a physics law to understand where the stock market is going to go. So that's kind of how we stumbled into oil and gas, and then we learned that oil and gas was kind of underserved by its current software. So there's a lot of legacy software that's like desktop software, not a lot of not full kind of transition to the cloud, and a lot of data that people are not using effectively. So people in the oil and gas industry generally feel like they should be doing something with all the data they collect, and this is like pressures and temperatures and flow rates, but they're not by and large. And there's this digital transformation idea that oil and gas companies should be getting better at technology. And Tachyus kind of like plugged in to fit that need.
Cool. Awesome. So, I mean, that's amazing. Like, it feels something like you took the opportunity and you exploited such a situation where you took what you're good at and what you're interested about and what's actually the people need and what's at the top, and you combined them and you made such a huge impact in the entire industry. Like now, like Tachyus has like one of the brilliant brains that actually make the optimization and gives amazing results for the people who are into oil and gas industry, right? That's crazy. But one thing that I want to know from your perspective, I know that you are you're a software developer at Microsoft back in like maybe 7 years ago. Mm-hmm. So where you were into software development, and there was a huge shift, right? You jumped right from a software engineer to directly into a CDO or a CEO, and which is totally different compared to a software engineering and oil and gas. How would that shift came from? So what was your stage at that moment? Like, how did you overcome like any issues that you have faced? What was all the things happening at that moment?
Sure. Well, I first of all, I had studied math in college, and I got lucky that I took this one computer science class that taught me how to pass all of the coding interviews at big tech companies. It was just data structures and algorithms and things like that. So I was able to just take about 5 or 10 interviews total. And by the time I got to the end, I had learned how to do a coding interview and got a job at Microsoft. So it wasn't like I had been into software engineering my whole life. It was just like I had the kind of math skills and wanted to be employed after I graduated. So that's how I got to Microsoft. And then at Microsoft, what I learned was that Microsoft was a great company and still is. These were in the Steve Ballmer days, and when I joined, it was right around the launch of Windows 8, which was I don't know. I guess Windows 8, you look back and it wasn't that successful, but it was one of the more ambitious things that, and I think strategically sound things that Microsoft had tried. There's the, mobile kind of Metro interface and Windows Phone. Anyway, so this is all to say that I was into Microsoft and I thought it was a good company, but my team was just not the kind of team that I wanted to work with as a 22-year-old. It was, we had a project that was shipping on a quarterly or biannual schedule. We would, I would write 20 lines of code a week and then pushing them through code review and testing and unit testing and integration testing. So it just wasn't the pace I was looking for, and I didn't feel like I was making the biggest impact that I could make. So around that time, I started kind of like putting out my feelers, and a friend of mine from high school who was already kind of an experienced, startup guy, had raised money before and wanted to start another company. He called me up and we just started talking through it. So the transition it wasn't so much, it wasn't so much like I became much more senior at that point just because I was called a CTO. I just kind of took initiative on my own to create something, and then I would have to, with my co-founders, I'd have to figure out how to sell it. It wouldn't just be on the Microsoft sales and marketing team to get it sold for us.
Cool. So that's amazing. Like, I mean, that was a huge shift. Like when you're in a situation where you got a great job in a great company that you've been there, and that's amazing. And we usually feel like, I'm done. Like, that's okay. Let's go ahead with whatever we have. But you took a chance that you let your passion and you let your, the next thing comes up and the next challenges that you took over and you made it, right? Along with your friends, and you took the responsibility of taking it forward, right? That's amazing. And how about like after it's been almost 7 years now, Tachyus as on the role. So can you just tell me like 7 biggest lessons from 1 year for each year? So what are those 7 biggest years that you could take away?
Wow, 7 lessons for 7 years?
Exactly.
Biggest lessons? That's a really good question. My lesson from year one, I'll just say the first ones that come to mind. I'm sure I probably have 1,000 lessons from each of those 7 years. But from year one, 2013, when I just quit Microsoft and moved down, I was working with my high school friend who was our CEO, and I was the CTO. And my biggest lesson from that point was you need to only have one person focused on coding and one person focused on talking to customers and marketing and sales. I mean, everybody on the founding team should be going and talking to customers, but one person needs to have their head out of the sand and looking at the market and looking at the customers and making sure that users are actually connecting with customers. And we spent like, 6 months coding, and we got to the right answer. Like we found the problem that we needed to be going after somehow. But we also spent a lot of time building things that no one ever saw because we were kind of insulated. So that was year one. Year two, I think the biggest lesson was we built out a big product. We raised a lot of money. I mean, we got some famous investors in Founders Fund, and that was all good. So the company was very, very hyped and doing well. And what I regret is that we didn't spend more time making sure we had a solid core product. And again, it didn't end up killing us because we've now built a really solid product. But I would have rather, in hindsight, I would have spent more time with 3 people on the engineering team building out something that really worked and solved the problem and getting some customers using it, even if they didn't pay a ton or whatever. Do we keep going here?
Yeah, you're just 2. You're more like 5 more away.
I've got two in. Yeah. Okay. Yeah, I just want to make sure you're still tracking the story. All right. So then year 3, this is 2015. At this point we had taken our initial product offering, and we had discovered that we could not only organize data for our customers, but we could actually learn from it and optimize. So that was our thesis all along, but it took us a while to really transition from just being a data collection product to being an optimization product. You obviously need to collect the data before you can do something with it. So what we were able to do is for these types of operations called cyclic steam or steam flood, where oil producers pump steam into the ground to improve the quality of their wells. Basically, they're reducing the viscosity of the oil and making it flow more readily. So we were able to figure out what wells to put steam into in order to increase their productivity. So this is like, you could spend millions of dollars on this, but if you put the steam in the right wells, then it'll go, production will go up. So with that product, this looked incredibly valuable to us. Like if we did the math, we could make a customer $60 million in 1 year just by changing where their steam was going with our physical model. So that was a very exciting thing. And if I were doing it again, I would have forgotten about any commercial proposals. I would have made sure that there was a customer that did exactly what we proposed from our model and made $60 million and wrote us a testimonial.
Awesome.
Because if we had just done that and taken the time to do that as a kind of early stage company, it would have propelled our growth from then on. But we got kind of stuck during a very difficult time for the oil and gas industry. There's a big oil price downturn around that time. And we were negotiating prices, and it kind of didn't make those pilots go as well as they could have. So that's 2015. Yeah. 2016. So yeah, we're now in year 4 of 7. This is one of the harder lessons to talk about. But there was a big oil and gas market downturn I just mentioned. Oil dropped from about $100 or $110 a barrel when we started the company down to $25 a barrel in January 2016. And I'll just do a combined lesson for 2016-17. But as the market was kind of climbing out of this, the company, I think, needed to make a pretty drastic strategic shift. And it's hard, especially as a first-time entrepreneur, to say we need to make this strategic shift and do something, for example, lay off some people or reduce our pricing or build a different product. And we ended up having to do all 3 of those things over the next 2 years. But had we done them immediately when it was the scariest and the hardest moment to do that, it would have been a better outcome anyway. So instead of laying some people off, a bunch of people ended up leaving the company, and we kind of went into hibernation mode for a year and a half. And then we started closing a lot of customers, and we really hit our stride at the end of 2017. So I forget what year I'm on now, but I guess I'll hop to 2018 now.
That's okay.
And I guess my lesson for 2018 is the customer is always right. So we really took our product to market. We were getting paid real money for it, making real revenue. Customers were taking our results and implementing them in their fields and seeing production increases. But there's also, we had to kind of reconcile our product with the old school way of looking at it, which is a highly trained engineer looks at a graph and draws a conclusion, and that conclusion may be different than what our software came up with. So instead of meeting them halfway, we were kind of, emphatic about this is, you got to trust the software. It's statistically, it's going to get you the best outcome. We should have done more listening during that time and made sure that we were making our product complementary to what people were already doing. And then 2019, we had gotten a lot of commercial success coming out of 2018 and 2017.
Cool.
2019, we were at a place where we needed to raise money because we weren't quite yet profitable. By that point, I had become CEO, and I don't know. I guess my only lesson out of fundraising is like be fundraising when your company's in a great situation and you don't need to fundraise. If you need to fundraising is really unpleasant. So if I ever start another company from scratch, I will make sure to get some traction, get a product that really has product market fit, have a small core team that isn't burning a lot of money, and then, go raise money to accelerate, not just to stay alive. So yeah, we raised our Series B in 2019, and since then, I don't know, 2020, I guess my lesson is don't, close your borders if there's an international pandemic spreading or something. It's not my lesson. It's a lesson for the world. But yeah, I don't know. That's we couldn't have done much to prevent that, maybe, but I think we responded to it pretty well, and we've done another strategic shift and built a couple new products. So yeah, that's I haven't been watching the clock. Maybe that was like the 7 years and 7 minutes or something overview of Tachyus lessons.
It's amazing. Like, I genuinely got it. I mean, the whole structure, I got to understand how many possible, challenges that you guys are being through the entire team and then all of that. So when you mentioned about, the first time, like in 2016, where you got the oil price drop, which is like a huge thing for initial days, right? So it's kind of like a recession in the company, right? Where people were having a lot of dependency for the paying jobs and all of that. So how did that happen? Did recession happen with the company, or how did you handle if there is a chance that people are leaving off because not well paid? So did you face any kind of situations just like that?
Well, I think the reason that people come work for a startup versus a big company is the same reason I came to work for a startup instead of a big company, because they want to be ambitious and they want to see the company grow,
Yeah.
and then ultimately they want to see that manifest as the share price of the company going up, and everyone at Tachyus, like most startups, has a big part of their compensation in terms of stock options. So if the company, if a company is flat or even slightly growing for a year, there are there are better options for a lot of people, or at least emotionally, like it can be tough to kind of stick it out and watch a company not make big commercial progress. Um, and I think I would have felt the same way. I mean, it was my company, so I had to stick it out, and I had to stay being a leader, and you know, the most people ended up sticking around through that period, and I had to kind of be the cheerleader for them. But I understand totally the people that left, and we've actually at Tachyus, a lot of people that left in 2016, 2017 went on to go start their own companies.
Cool.
So we've had at least 10 people have left Tachyus and started new companies of some kind. So that feels kind of good, and I like to think that if nothing else came out of that downturn period, we got a lot of people who learned a lot and got to go become entrepreneurs on their own.
Yeah, and absolutely. Like when, yeah, and also when you say about like the 2015 days, where that you actually got a chance to prove the work and the software that Tachyus has been building upon, making the things optimized and making the things getting a better and better results with a lot of cost effective and the resource effective, all of that. So initial days are always so hard to get a customer and make them trust your product, make them believe in your product and get their things done, right? So how was that situation like? Did people trust you in a way, or did they say like, how could I, is that really possible, or how was that?
Well, I think it comes down to how you communicate. If you say, do what we tell you and you're gonna make more money, it's kind of like, who are these guys that have never worked in the oil industry before and want to tell me how to run my business? So, but if you come in and say, here's something we discovered and we want to share it with you,
Yeah.
then I think it can be a different conversation. And that's the kind of conversation we're having these days. But in the beginning, it's tempting to say, here's like $60 million. Why don't you give us $10 million for it, and we'll call it a great win for you or something. So I don't know. You need to be giving wins to your customers and helping them be more successful, and making their lives better in some way, regardless of what kind of product you have. But you can't pretend you're their savior or something like that.
Cool. I understood that. So yeah, I get that. So and also like, what about this? Like getting an investor maybe around for Tachyus, it happened around like 2000 and maybe 17. Is that so? Like if I'm not wrong, 18.
Yep.
Yeah. So but getting an investor to our initiative and making them believe in our work is kind of tough thing for investors as well, not only for the customers, but also for investors, and making them raising VCs or venture capitalists. Or I know like Tachyus has been raising over like 15 millions of dollars, right?
Yep.
So how about like for initial startups? So at what time, like how do they could figure out their time so that they could reach out to VCs or any other people so that they could get investors to fund back and they can grow further?
Yeah. Well, we actually raised our first money in 2013. We raised a small seed round, and then we raised a series. Well, we raised a seed, I guess we call it after the fact, in 2014, and then we raised a Series A in 2015. And then we raised an extension in 2016, and then we raised a Series B in 2019. So we've kind of been raising money all along. And the main thing I learned, I guess, to answer your question, is that it looks very different depending on the stage that you're at and the amount of money you're trying to raise. And I think there's a lot of, well, yeah, I guess it depends where you're coming from. If you're in the right networks and are have your company that's reasonably well marketed and successful, it should be easy to find people to give you like $500,000 or $1 million to go build it out and, build a product, build an initial team. I guess those are like either seed investments or angel investments, depending on who you talk to or just what you want to call it. But that's basically an investment in a person and to some extent an idea. But mostly investors at that stage are investing in the team. And then when you get to a Series A, they kind of want to see that you've really built a product and you're taking it to market effectively, and that there's some promise maybe of product market fit, like you're on your way to it. People are actually maybe buying the product. Plenty of Series A companies, I think, don't have revenue, and we didn't when we raised our Series A. But we had a product and we were taking it to customers, and we had discovered, I think, that $60 million optimization that I keep talking about.
Cool.
And then beyond that, it's really there's no way to fake it anymore. So when you're at the Series B stage, you really need to have product market fit measured by paying customers, at least in B2B. If you're selling software to businesses, it's not like TikTok where it's just the number of users that are on the product that values the company. It's like who's actually paying. So the number that we've always had in our head is like we need 3 real representative long-term recurring revenue customers to get after a Series B, and we ended up getting probably 3 or 4 by the time we raised our Series B, if not more. But you actually have to turn your idea into a business to keep fundraising after a Series A.
Yeah. Cool. Yeah, that should definitely help to the people out there who are actually trying out to get the fundraisers, and they would be definitely having this question like when they should start doing it or when should they start experimenting on it. So I think this should be helping them as well. So about the book, right? There is an amazing book by you from the Manning Publications, right? Math for Programmers. And in the very beginning of the pages, that's one thing that literally attached to me is that a real thing that actually happened to me in your words. So what was it? There are some people fascinated about math and they devote their whole life into it, right? While others, they just don't like it and they don't get it.
Yep.
And by the end of 12 years, we would be probably all being forced into one groups or another, right? So that's so genuinely like till my 10th grade, I didn't actually understand what math is all about. And those formulas literally didn't speak anything to me. And later I picked out realizing how much mathematical impact can be in the real world. And then that's amazing, right? So what do you say about this? Like, why do you think that the children at the young age get afraid of math and how they could overcome such math anxiety, like what you mentioned in the book?
I have 2 answers to that. One is like a harder one because it's like how education is done, at least in the US. Like math education it's not like a literature class or something like that, where it's like in literature you're reading books because it's like you learn something about the human experience, and you develop in some intangible ways. Criticizing like Shakespeare or something and writing an essay about Shakespeare isn't a skill you'll ever use in your life, but there are, we could go into ways that that's important. But math is never taught like that. Math is taught like you need to learn this skill as a means to an end. Like learn trigonometry so you could like be a surveyor on a construction site, or learn calculus so you could like be a rocket scientist. And not everybody wants to do all of those canned examples. So it's like, people don't appreciate math as like a creative human endeavor. They think of it as a tool and something that's right or wrong. But it really is like an exploratory process, and it is a creative discipline. So I think that's the first big thing, is changing how we think about math. And another example I always love to give on that one is if someone asks you like, oh, what are you reading right now? And you say, oh, I don't read books. I'm just not a reader. Or I don't read literature or something like that. You seem uncultured and you seem like, what is this uneducated person doing? But if someone, it's very socially acceptable to say, I don't like math. I'm not a math person. No one looks down on you and thinks you're unintellectual. So I think that's a cultural thing, an educational thing. And those should both be fixed. And there are a lot of people that realize that. So hopefully it will be fixed. But the other let's see. Remind me. You have to remind me of your question. I had a second answer in mind that I wanted to give. Yeah. So another reason I think people have math anxiety is I like to think of math. I think of it a couple different ways, but one of the perspectives I have on math is it's kind of like an intellectual bodybuilding exercise. So the same way you show up at the gym and you like, I don't know if you ever spent time like weightlifting, but you go into the gym and you pick up some 5 pound dumbbells and you're like, wow, I can do this, but it's kind of tiring. And then next to you, there's some like beefy bodybuilder that sits down. He's got these 50 pound dumbbells and he's doing the same exercise as you with 10 times the weight. And it can be intimidating and you can think, wow, there's no way I can do this just because there's this exponential progress that you make. And it's made over years. And the same thing is true in math. It's like a real training of your mind that you have to commit to, and you're going to not be working on the hardest problems, and you're even going to be doing easy problems and failing on them for years before you get to hard problems and you get to fail at those. And then eventually you'll get the hard problems right, and you'll get a lot of self-confidence.
Yeah.
And you'll be like the guy with the 50 pound dumbbells. But I think you need. It's the same reason people don't go to the gym, right? Like people get freaked out when they show up to the gym for the first time.
Yeah.
So I really like that metaphor.
That's amazing. Like that's actually the way that if that is how the people would be thinking in the young age, then definitely they would be sticking with that so that they could become more stronger, more potential to solve more problems, right? So that's amazing. Like that should be taught in the initial days, right? So when we try, getting into schools and 10th grade people, we usually find people saying like students are all like, they complain like, I don't know where I use this physics or mathematics or chemistry that I learn in college or school. Like, oh my God, like I don't know where I use it. I mean, that takes off that curiosity, that takes off the energy to learn something, right? So did you face the same thing in the initial days of your childhood when you started learning about physics and mathematics and chemistry, all of that? And also like people, how could like kids can actually understand the actual use when they learn it?
Yeah. Okay. So I did feel the same way. And I definitely didn't have a, smooth path learning math for my and science for my whole life. I really felt like at times I was not cut out for it, or that I was not the best, or that I was the worst, or whatever. Like there's all these feelings that you can get in your head, or that it wasn't useful, or all these anxieties that people have. And I think a lot of those came from specific classes or tests or things that I went through, kind of like, the hoops that you jump through in education. One time I remember this because it was such an ironic thing, but I got accelerated in 8th grade to do, I was algebra class, and then I was doing some like extended algebra work kind of independently to accelerate because I was doing well enough in algebra class. And as a result, I still had to take the algebra tests, right? Because I was still enrolled in the class, but I hadn't been in class, so I didn't do well on them. So I had been trying to learn ahead of the class, but ironically, it made me do worse, and I fell behind. So it's just stuff like that where the education system doesn't set you up well in some cases. And I don't know. Like I said, people are working on that, but that's I think something that can be felt. And then in terms of learning where you're going to apply it, I think part of it is you get an instinct. Like I don't use a ton of math on a day-to-day basis in terms of like, I joke to some people I've used a logarithm like 3 times in my professional career. And one of them was to measure how wide a number would be on a graph to make the graph labels look well. So, it's just silly things like that. But you can think about mathematical reasoning and logic more broadly. And that's I think something you have to kind of experience to get. I mean, it's the same as reading Shakespeare. It's hard to say, oh, like read Shakespeare and you'll like develop as a person, and someone believes that. But it's the same thing as with math. Like you learn some logical thinking tools. Like one example is methods of proof by contradiction, proof by construction. And if you learn those things, then you kind of intuitively apply them throughout your life. Like if someone tells me, someone makes a statement about the business, even like we can't close this customer by this date because of this. I start to think, is that like a logically sound reason? Is there something,
Mm.
can I not like construct an alternative that would like refute their premise or whatever? And this is not like I'm being a Vulcan or something. It's just, you think critically and you think logically and you think about how information is organized.
Cool, cool. That I never thought of this. I'm telling you, like this is so cool. Like this should be actually deserves a try. Like when we actually in the same way, like instead of looking in the perspective of kids, let's look into the perspective of teaching, right?
Yep.
So teaching mathematics or physics or anything. So when we try teaching someone about something, and subconsciously we create a pattern or a unique approach of communicating intuitively to others, right? So what is your approach? That the subject is so vivid and clear to the others, like specifically mathematics?
Yeah. So I think unfortunately, I had a ton of ideas, but I'd never written a book before. So it was like a little bit harder and it didn't turn out as perfectly as I expected. Not that the book is bad, just saying like my path of writing it was not like, I took all of my theory about how education should work and it just like went seamlessly onto the page. It's a lot harder than I expected to explain ideas and especially to explain them on the written page. But the philosophy that kind of guided me was, I guess there's one main philosophy. So the first one is that programmers have this intuition about rigor that comes from the computer. So if you type code that's like plain English, it won't do anything. If it has to be exactly the way the computer wants to get it. And if there's anything wrong with it, then the computer will spit out an error, down to a semicolon, or you type x. One example I give in chapter 1 is like x equals 5 versus 5 equals x. And in math, they mean the same thing, but you have to know you're talking in a formal language to the computer, and x equals 5 means set x to 5. And then the other one may or may not mean anything depending on the language. So that I think is that's a foundation, I think, for programmers to learn math, because mathematicians have proofs. Mathematicians say this is true because I have these other things that are true and I combine them and then I get to this new fact. Programmers mostly don't know how to write proofs.
Exactly. Yeah.
Like programmers can't read proof-based textbooks, and I think that's a problem for a lot of programmers. But not to say that they're stupid for that reason. It's just a very specialized skill, and I think that the idea of using the computer as your way to enforce rigor and correctness is almost as good as a proof. I mean, it's not deductive logic, but if you can code something up and your implementation works, that's a pretty good suggestion that you've done the math right.
Cool.
And I guess I have the one other thing I'll add on that topic, is that calculators are really important in math versus broadly. I guess that's a broad statement, okay? But then they're also important in math education. Like I used a graphing calculator a lot in high school. I don't know if that's still I don't know to what extent people do that or if it's still popular or whatever. But we had to like plot a graph and look at the graph and compare it to another graph. And before graphing calculators, I imagine there's a lot of like picturing and you have to devote some of your mental energy to thinking, what does this look like compared to something else versus just looking at the picture. And so as calculators become more powerful, you can do, you can think about harder problems because the computer's kind of helping you along the way. And I think that's another way that programmers are really inclined or disposed to learn math or whatever, because they've got the best calculators that are available, which are high-level programming languages. You can make a graph in Python. You can do any arithmetic in Python. You can do calculus in Python. You can do linear algebra in Python. So
yeah. Absolutely. So, and also this is going to be like we're going to be ending very quick. So how about it? Like I have found like Tachyus uses FSharp as a language for building softwares. So, which is actually kind of unpopular, but very powerful.
Yeah.
Right. So can you speak about the FSharp, like where that actually uses in oil and gas industry with softwares, and why specifically FSharp?
Yeah. So I think I first of all, I ran an FSharp at Microsoft because my team at the time was the same team that had the FSharp tools. So I didn't work on FSharp, but like a couple of my teammates did. So I got exposed to the language there and I at least got curious about it. And then I got an intuition when I started using it that it was very like mathematical flavored, and I didn't really know why, or I couldn't tell you exactly why it was mathematical, but it does have this feeling, and most people that use it will tell you that. And then there's also this aspect that FSharp is strongly typed and functional, and those aspects kind of make it easier to write correct code. So you can write something, and the compiler will be very strict about checking your code and making sure that it doesn't have bugs, and essentially, and that people will say that if your code compiles, it almost never has bugs at runtime, and that's not quite true, but it kind of feels like magic when you start doing FSharp. And since then, I've actually realized that math is there is like some very exciting underlying math about functional programming, and it's mostly this branch of advanced math called category theory. So I wanted to write about that in Math for Programmers, but it's way beyond the scope of the book, and you'll have to keep your eyes out for my second book where I will get into category theory.
Cool. So that should be really good. There's a lot of 5-star ratings for the existing book. So I wish it should be having the same sort of results for the coming up book as well. So that will be definitely. So
yeah, thanks.
That's how we are on the edge. So Paul, do you want to share something to the listeners, maybe for the maybe for the startup guys, or maybe they are trying out to learn machine learning, or they are trying out to get into mathematics, or if you want to share something, yeah, feel free to.
Yeah, sure. Well, I would just encourage people to I don't know. I have this crazy idea that if you learn a lot of math, it will lead to great fortune and success and fulfillment. So keep learning math. And I would also say take the risk and start your own business, because that's going to be, for a lot of people, that's like a great way to find fulfillment and to really contribute some like meaningful skills to the world. And I would also say if anybody wants to talk, I'm generally open to, if you want to reach out, I'm paul@tachyus.com. I will, if I get your email, hopefully I will respond and have time to talk to you. I'm always interested in talking to people that are starting companies or even thinking about it, and happy to be helpful in any way I can.
Absolutely. I mean, this is really honest. Paul is so much open. You could definitely give a quick email so that you could respond maybe in 24 hours. That would be really good. I'll drop all the emails. I mean, I'll drop your email address along with your LinkedIn ID so that they could definitely reach you out. So that should definitely help them.
Awesome.
Super. Thank you so much for joining us, Paul. It's an amazing conversation for entrepreneurs or educators or learners or getting into machine learning or oil and gas, kind of an intersection, most of them. So definitely, I think it should be a huge impact for all of them. They could take something away from the conversation, and they could have a change in their daily life, a change in their learning paths. So thank you so much for joining us.
Yeah, thank you. Thanks for having me.
If you are the one looking forward to adapting machine learning into your career, take a look at our sponsors, Sundog Education, and start free trial with a lot of hands-on activities and exercises. You can practice whatever you have learned. Visit sundog-education.com and you can find all the direct links in the episode notes below. Thank you.